Let's continue with María Paz González. She's an agricultural engineer with more than 15 years experience in anaerobic digestion. She heads the bioenergy and biorefinery line at AINIA, a private tech center with more than 30 years experience in RD&D. María Paz, you have the floor for your presentation. Thank you. Thank you for inviting me. And the aim is to bring closer to you what we have done in the LIFE REPTES project. And I'll be here all morning, so feel free to ask me any details you need. And here I'm bringing the biohydrogen or biogas production from lignocelulósic waste and cofermentation with sewage sludge. Very quickly, we need, as an introduction, we need to think that it's been mentioned about the rice straw. Spain is the second producer of rice in the European Union after Italy. In Spain we have Andalusia, Catalonia, Extremadura, and of course the Valencian region. And in the Valencian area we have rice crops with more than 14,000 hectares of production. So we have a production linked to the ecosystem because it's done with a flooding system, and to keep the rice crops and biodiversity, these locations need to be kept. They're usually in the Albufera area, and we need to have a low environmental footprint in a sustainable manner. So we have this rice production, and we also have the annual generation of certain amounts of rice straw. And in the former debate, it's been mentioned that for years people have been working on different alternatives to manage this rice straw. In our area, in the Valencian area, burning was quite usual. Burning entails environmental and atmospheric pollution problems, which are quite complex. Other alternatives have been approached, as well as management strategies. Here are the main ones. And the second main one could be the addition to the soil, the sludging as they call it there. And it's not a solution, many others have been researched. And here we have emissions associated to the different alternatives. The third one, the incorporation of straw, has carbon dioxide emissions that are quite relevant. So in this context, we keep needing to find solutions that have a low carbon footprint and that solve this problem as much as possible. In parallel, as mentioned in the former presentation, we have existing digesters and the possibility of using certain co-substrates in filtering units with a good design so that we're able to add more organic matter. In this case, we have a Pinero filtering station. The production is 24,000 cubic meters of biogas per day. The production varies per month, and they currently have 30% of the biogas production is used for self-consumption in the wastewater treatment plant. So we have these two situations in parallel. In this context, the idea comes up to have something that integrates both situations and improves the current management alternatives. Here's the general outline of the project. We need to work a lot in pre-treatment. In the case of rice straw, we need to do certain pre-treatments that enable the incorporation, and besides, since it's a vegetable co-substrate, we have yearly storage. Regarding prior projects, here they define how to do the storage with the siloing and how to enable that mix in the digester. By extrusion was chosen. Regarding the treatment process, we work with pasteurization. The process comes later to eliminate certain microorganisms, and from there we make the mix, where we go to a first stage. In this case, we decided to work with starch fermentation to produce biohydrogen. The second stage for biogas production. Even though here in the outline, there's no on-site usage. There are models for hydrogen usage as fuel for agricultural matters and use in biogas for self-consumption. So to mention these stages and to give you just a few hints, here we have worked on siloing at industrial scale. We already have real data about the functioning of these storage, as well as bioextrusion tested. And why do we do this? Well, the siloing allows us to save problems regarding the auto-combusting of straw. It also allows us to have that substrate stored throughout the year. So it's a specific point, a specific moment to collect rice and dried straw, but ideally we should have yearly maintenance of the substrate and the biogas plant. Here we have the siloing treatment maintenance. And regarding the rice straw, we need to see how to break the structure and make it bioavailable to kind of make it and release it for microorganisms to attack it. So we work with bioextrusion, and very importantly, we need pre-treatment to favor the mixture of straw with other elements. That was an essential condition in this process, so that it can be pumped and so on. And in parallel, we have the need in the sludge to eliminate certain mechanisms. We have chosen dark fermentation and to apply certain thermal pre-treatments. Here in the treatment plant, thermal hydrolysis is implemented at an industrial scale, and here we have seen that they had that thermal hydrolysis pre-treatment, and we try to simulate the sludge available in the treatment plant and on the primary sludge that does not go through thermal hydrolysis, we have applied pasteurization. All that with the target to prepare the substrate for the target bioprocess. Something important here, how did we work with this dark fermentation process? We have the lab scale results. We have worked on pilot reactors of 30 liters. We have monitored hydrogen production. And why did we do these trials and adjustment? Well, before the demonstration, we wanted to optimize and get to know better the operational conditions that were most appropriate for these waste mix to reach the biggest concentration of hydrogen and production of fermentation gas. And here we have two of the operation parameters. We have worked with more processes and parameters, but most importantly, please remember that we work with low residence times and adjusted pH to maximize acids and biohydrogen production. We have two stages. We'll also work with the liquid effluent of the dark fermentation in the anaerobial conventional digestion. And here we are after the design stage. This is a consortium project where we work with TAM, HENI, and Consorcio de la Ribera, and we have the design and the different equipment. We will work with 250 tons of rice straw per year, and we have bioextrusion at the demonstrative scale, and we'll work with that. We have the siloing ready that will be taken to the wastewater treatment plant, and we're now in the stage of building the digester for dark fermentation. As you may see here, will be about 15 cubic meters of the reactor, and the aim is to at least improve the conditions we obtained in the pilot scale, so that we can have 30% of hydrogen, at least half cubic meter here, and that effluent will be worked on, and we'll measure the anaerobial conventional digestion and the performance to see also that possible self-consumption improvement to have 30%, and if we can improve that further, let's see how far we can go. And I'm now reaching the end of my presentation, and to link it with the introduction, we have calculated the tons of rice straw that we could use for anaerobic digestion at the wastewater treatment plant. Era Pinero has a capacity to potentially treat up to 15,000 tons per year of rice straw, so that's about 15% or more of that rice straw management. And last, as a general result, please remember that these kind of demonstrative projects aim to offer an alternative to the current management and assess the performance demonstratively and explore new ways for hydrogen with a low environmental footprint. Our steering and temperature moderate, and all these performance results should be useful to check the limitations and all the scalability of the project at a larger scale, both for hydrogen and or biomass, to check their usage possibilities. Last, I'd like to thank the LIFE program that is helping achieving this project. Thank you so much, everyone.